Hey guys, you're welcome to West Africa YouTube channel where we educate African developers on how to write smart contracts and build dApps on the West blockchain.
Hey, we're going to be having an introduction to the right smart contract programming language for the Waves blockchain platform. Right now, we're on the right official page, and this bad boy have a whole lot of features which would really be needed in making a smart contract. As you can see, the official slogan for RIDE is less code, more power, and it does just that. Let's look at its features. You can see RIDE is straightforward, it's concise, it's human readable language, and it also offers reduced development time and resources. You can easily get started with RIDE even on your web browser using the Waves IDE. More on that later. And it's fail proof. It's secure in the sense that it was designed to avoid critical mistakes that you would normally have to look into when developing smart contracts in other smart contract programming languages. And it's modern. It's formal, verification friendly, it's lazy execution, and a modern typed functional approach. It's predictable. There is no gas fee in deploying right to the blockchain. It has a flat fee, so no matter the size of your smart contract, it always have to be a fixed flat fee. So I think that's also useful for us as developers because we get to know what our smart contract is going to cost to deploy it even before we deploy it onto blockchain. So it's developer friendly, like I said, with Waves ID for learning, and it's also a sandbox where you could prototype your smart contract before you move onward to more sophisticated development IDs or technologies. And it's very useful. Immediately you can start building dApps or smart contracts for donations, for escrow, for referral, and for loyalty systems, gaming, and so much more. So RIDE is really pretty simple, pretty basic, and I'm going to introduce you to the syntax and how you can start developing with it using the Waves IDE. So like I said, the Waves IDE is an online IDE which you could use directly on your browser where you could start prototyping and developing RIDE. So it's pretty convenient. It has syntax highlighting, IntelliSense, error inspection, interoperable. It works with all the networks on the Waves blockchain, so you could get on to mainnet, to testnet, or a custom network, which would be highly needed when you want to develop locally with more development environment. And it's all in one. It has an REPL. You can write your script code. You can also write your test code. So it's pretty versatile and pretty user friendly. So let's take a look. Don't take my word for it. So let's look at the Waves IDE right about now. Okay. So I'm just going to ide.wavesplatform.com. And then you can see. So I quickly click on the settings, so I get to show you how you could set your development environment. So right here you see the theme section where you could change your theme from light to dark. I kind of like the dark theme, so I always leave it at dark. Then you could set the timer. So all these other features are kind of like advanced. I think the default is safe enough for you, but to change the node you're going to use, so by default it should be on testnet, but I've been working on IDE, so I'm right now currently on mainnet. So if I click on this checkbox right now, I'll take it to testnet. Okay, I need to testnet. So when I click OK, the environment is now on testnet, and I'm going to quickly close up all these other scripts which I've been working on. Then I'm going to look. So if you click on this plus button over here, you could see the option to create a whole lot of scripts and also to create tests. So for this introductory video, we're just going to create a dApp script and I will explain what's going on in the dApp script, and we're going to use the Wave dApp Explorer in order to interact with our dApp. Okay, let's get right to it. So clicking on dApp will create a file underscore one.write for me. I don't really like that name, so I'm just going to quickly change it, and I'm going to call it the wallet.write, because we're going to use the wallet snippet on the official Wave Write page in order to explain right. But before that, let's look at different sections. So this first section over here is the compiler directive in write. And what it does, it gives info to the write compiler on what kind of script this is. Like I said, write have different sort of scripts. We have access scripts, we have account scripts, and we have dApp. So the dApp is what we're interested in, because we want to be able to interact with it outside of the blockchain. So here is telling write to use the standard lib version 3, which is the highest version of the standard lib currently. Then the second directive is telling write that this is a dApp, so any feature, any language construct that is needed for dApp, write will be able to pass it via the compiler. Then the script type is telling is an account script, because we're going to deploy dApps into accounts. So we deploy dApps into account, we deploy asset script into assets. Okay, fair enough. Good. So right now, this is just a boilerplate callable. So what the callable is what the outside world can interact with your smart contract. So this is the mechanism where the outside world can get to interact with your smart contract. So it's like the API for your smart contract, right? Now this verifier function has been commented out. What it normally does is to safeguard, if you may, in terms of the kind of transactions that the smart contract would allow when it's deployed on an account. Alright, so let's quickly copy the wallet.write code from here, like so. So I'm just going to copy the callable. I'd copy the entire stuff, and I would paste it here. Yes. Okay, so that's good. So what's going on here? So if you could remember from our intro to write, you could see that write was inspired by Scala. So most of the syntax, if you've written any code in Scala, you would understand that there are some few similarities, right? Like the way a function is being defined and all. So right now we are creating a deposit callable. Alright, so this is a wallet smart contract, and what it does is allow different accounts to deposit money or their waves coin onto one account and be able to withdraw it via this callable later on. So it's like a collective account where you could deposit money, but you cannot withdraw the amount you did not initially deposit. So let's see how write helps us to achieve that. Okay, so the first line here is how we define variables in write, and we're defining a variable that is PMT, short for payment, and we are from the I argument that being passed to callable. So it means invocation. The I means invocation. It means it's an object containing details about the account that is invoking this callable. So whatever account calls this callable, I represent that account. So now we are using the extract function to extract the payment from the invocation. Okay, so the payment is going to be in waves. So now we are checking using the if conditional. We're saying if the PMT has an asset ID, because by default, if the wave has it could be different coin or tokens on the Waves blockchain, right? So we only want waves to be deposited in this account. So because of that, we are going to check if there's an asset ID. So if there's an asset ID, that means the user is trying to deposit tokens that are not waves. So we're going to throw an error. I'm going to tell the user can hold waves only at the moment. So else, if there's no asset ID, then we could create a current key using the user's public key. Alright, so this function right here would convert a base 58 data to string. Alright, so we want to store this on the blockchain. Alright, to be able to do that, we need a key and a value. So to create a unique key, we're just going to use the user's public key that is invoking this deposit callable. So after doing that, we need to get the current amount. Alright, so we are assuming that perhaps the user have deposited before, so we need to increment the amount that is deposited or just return 0. So using the match syntax, we're going to check. So the get integer is a function that takes two arguments. One is the account or the script address, which is this. So this means that, okay, you're going to check the data storage of this smart contract account. So the account holding this dApp or this smart contract is what we are querying to get the amount. So we pass in the key. So the key is like this key right here that we've created. The key is what is the unique identifier for every value entered into the blockchain via this dApp. Alright, so we say case A int. So case A int is this syntax is that A is just a variable, int is the type. So since we are getting an integer, we're definitely expecting an integer, right? So we're saying that if there's a value over on the blockchain, we want it to return it and save it on current amount. If there is no value, then return 0. Alright, so that means the user haven't saved before, haven't deposited before. So with that, we create a new variable with the let syntax for new amount, and we're going to just add payment amount to current amount. Then after that, we're going to use the write set. So the write set, it's a data list entry that allows you to pass in an array of data entry. So anytime you want to write something onto the blockchain, you use the write set and pass in an array of data entry. You could pass in more data entry if you want, but for this case, we're only having one element, which is the single data entry for this amount the user just deposited. That's fair enough. I hope we get that. So after that, we're going to look at the withdraw callable. So definitely the user will need to withdraw his or her token or coin or waves from the wallet that is being held in. And with that, we are going to say, so how do we get access to that? So we're going to use the current key as well, right? So the current key, if you pay attention to the deposit, we're using the i.color.bytes, which I said it's the public key of the user. So we're going to use the same public key to be the current key, and we're going to match. Using the match, we're going to check if there is an amount. So we're going to check if the user has a current amount. So let new amount equals to current amount minus amount. So that is what we are reducing the amount the user wants to withdraw if it's there from current amount. So if amount is lesser than 0, we're going to say we cannot withdraw negative amounts. Of course, you don't want to withdraw negative amounts. Then else if new amount is lesser than 0, that means the user does not have enough waves in its balance. Okay, so if either of this is not true, that means the user is not withdrawing zero, and it has enough waves in his account to be able to withdraw that amount. So we're going to do a script result. So the script result, it's a function that can take in write set and transfer set. So it enables you to be able to write to the blockchain at the same time as perform a script transfer transaction. All right. So with this, we're going to write the new amount onto the blockchain, and we're also going to transfer the amount the user wishes to withdraw to his address. Okay, so that's it. So you could see with this short line of code, we've written a wallet dApp, and it's so easy, so straightforward, and I believe at a glance you can be able to understand what the smart contract is doing, which is one of the selling points of RIDE. So RIDE is saying that you do not have to have a very complex, long lines of code in order to be able to do something productive with the smart contract language. With just like that, you can prototype a smart contract and deploy it onto the blockchain. Coupled with the Waves IDE online, writing smart contracts have never been so easy. Okay, so one more thing before we go. I am going to, after I did this verifier, so what I want it to do is I want to be able to match TX. Alright, so I want to say the case of script invoke script transaction. Okay, quickly I just grab that. So I'm going to just say seek verify for the invoke script transaction. Okay,